everybody, and again, thank you very much for staying here and discussing how the cloud is really transforming the way we do business today. And today, it's just phenomenal when you see these large enterprises leveraging the cloud. It's fundamentally changing how we think about businesses and products and so forth. So today, I'm going to talk about, most of you were there in my TCO session. Now I'm going to talk about more on my second favorite topic, which is big data. These days, big data is a big buzzword, and I hope to change, or I hope to tell you, convince you that when you think about big data, the word big data has really emerged due to the cloud. And I'm going to share with you now plenty of stories, lots of ways in which how Amazon does it today, and also kind of share a bit about a story around why big data matters today. So at the core of any successful company today is the data that it manages. And nobody more will be understanding this better than the people in this room today, because most of you are dealing with large amounts of data all the time. And the way you model, you analyze, and process that data truly identifies or truly distinguishes your company from the rest. And the way you can derive valuable business insights, valuable business knowledge, or distill information out of that data, you will be having much more better competitive advantage over others. And that's where cloud really comes in play, that it allows you to really think about data without limits, compute without limits. It gives you this enormous power to really execute in a way so that you can not only take and store existing data, but also process, analyze, distribute, share, collaborate with others in the world as well. So with that, I'm going to talk about three main things today of why big data really matters today, what has changed in the past, from the past, and why it is so relevant today, and why it is so important for everybody. Then I'm going to talk about now how AWS really addresses that big data challenges that is available, that's out there. There are several challenges that goes when you build massively distributed parallel processing pipelines, and how AWS really is a sweet spot here, and how AWS will help you build that processes in place. And then I'm going to share several stories around different use cases, which will from a variety of industries, including banks, that are leveraging big data in the cloud. So why big data matters today? What has changed? And if you think a little bit like in the old days, what used to happen is my senior management will come to me and ask me a question that I want a nightly sales report. They knew a nightly sales report of every single product, right? And they knew what questions they were going to ask. And the questions that they are going to ask actually drove the data that you need to collect. That data that you need to collect actually drove the schema and the model that you need of how you're going to store that. And that model actually derived the algorithms that would process that data and give you that nightly business report. So because you knew the questions ahead of time, that actually drove all that in a way. There is fundamentally, the things that fundamentally changed from that in a way that now the philosophy is totally changing in a way that now they don't know what questions they are going to ask ahead of time. They want the data to be collected. The philosophy or the mantra has changed from collecting data to collect and measure everything. We'll think about data later on. Think about, questions later on, and what ad hoc questions can be answered. And the fact that when you actually, it is extremely prohibitively expensive to run now ad hoc queries in the previous scenario where the data drove the business model, data drove the object model and the storage model, and that storage model drove the algorithms. Now you want the data to be there because your raw data is really going to help you give valuable insights from your existing data. Also, you want to merge your public data sets from private data sets and actually derive even valuable insights out of that big data too. So you want your data to be available, you want your data to be, you want to measure and collect every single thing, and that gives a massive challenge of how to store, how to analyze this massive amounts of data that you have, and how to actually measure and qualitatively and quantitatively create a framework so it is easier for you to process these ad hoc queries and do a pre-computed indices so you don't have to do a full scan of your existing data set. And that's why I feel big data really matters today, because it fundamentally shifts or changes the way how we ask questions. Instead of getting a nightly business report that a senior business executive will ask, he will say, I want to ask this question, I want to take this other data set from my other part of the company, I want to take public data like weather and local and other public data sets that's available, mash it up together, give me a report that will actually tell me how the sales are doing and why it changed or why it is going up or high and so forth. Take competitive information from other parts of the company, other parts of the industry, and also merge that data set and show me valuable insights so I can make the right business decisions quickly. And that's the reason big data is really, really important today. Data is the next industrial revolution. Data is the new raw material in par with capital, labor, and people. They are, today data is apolitical. I cannot go into a senior management meeting without getting data, without having data. Data is not only important from a business standpoint, but also it is important for decision making in a way that opinions don't matter. Data will help you build and take the right business decisions itself. So big data really matters today. Big data is how the data is collected. So it's not just about storage when it comes to big data. It's about storing, analyzing, distributing, processing, sharing, visualizing. All of that is what I think big data is. And that's why if you're able to analyze and distill information out of that data set, get valuable insight and take better decisions, it will give you higher competitive advantage. And that's why big data is really, really important today. So if you have lots and lots of data, it won't do much. You have to have compute by the side to really give you the right necessary big insights that you are looking for. And that's why cloud computing really helps you, give you that better processing power, the necessary horsepower that you need to actually not only process them in a cost-effective fashion, but also that you want to take your data and apply multiple different algorithms on it. Sometimes Hadoop, which is a very good processing framework, open source. How many people know about Hadoop? Oh, quite a few. Sometimes Hadoop is the way to go. Sometimes, it's some other technology that is available which might be the right way to go. MPI, or even generally any other data warehousing technologies that are out there. You might want to take that data, analyze it across multiple data algorithms, and apply multiple different ways to actually gain necessary business insight that you need. So it's very important to understand that giving that and keeping your data, analyzing it multiple data options or analytical options, analytical frameworks will give you the necessary business insights and so on. So this is why I think why big data matters and why big data is really important in the context of the cloud, because cloud is really what is powering big data today. So let's talk about a little bit about how AWS really addresses this big data challenges. When you have terabytes and petabytes of data, there are multiple challenges that arise. Now you want to move that petabytes of data into the cloud. Today we talked about a variety of different partner solutions as well as different options available so that you can move massive amounts of data in the cloud. As well as now I'm going to focus on not only moving data, ingestion of the data, but also compute and analyzing it. So some of the big data use cases that I concentrate on are around. There are a variety of different use cases today. One is media transcoding, large amounts of video, and large amount of transcoding. Today, John is going to talk about, from Zencoder, going to talk about how they leverage this cloud computing for this massive video transcoding pipeline that they have built. It's really cool. Every company has logs. Every company has lots of data that they would like to get processed and get generated reports. So retail log analysis is also one of the most important use cases. Web analytics, data warehousing, digital advertising, financial modeling, Monte Carlo simulations for financial services. All of these are important use cases where cloud is really the sweet spot. And I'm going to talk about a few such use cases today and how Capital IQ and Bankinter are leveraging some of the cloud services in here. So kind of understanding one of the core infrastructure pieces of how AWS really enhances the whole entire the big data processing pipeline is where I want to focus on next. So you have data from multiple different sources. A cloud gives you an enormous conceptually infinite capacity to store that data, normalize that in a way that you like, using the computing services that's available. So you can store, you saw there are a variety of different services today regarding S3 and EBS and a relational database service, which help you build the right level of data and so forth. Right level of data can be put in the right level of framework. So when you want to move large amounts of data, what are the different ways that you would like to move? And I have this small little chart which essentially kind of talks about if you have gigabytes of data and if you want to move quick enough within days, let's say, then the best way would be to transfer S3 over general your customer pipe. Or the pipe itself that you have. So you will be able to leverage the distributed aspects of it. You have multi-threading, have multiple connections to upload your data using standard internet connection over the internet. For gigabytes, and if you wanted it within hours, we'll advise you to move that big upfront, the big chunk earlier, and then have Delta uploads typically. One of the features which was not discussed earlier is this really neat feature called multi-part upload. Jezo mentioned earlier that there is a way in which you can upload up to 5 terabytes per object size within Amazon S3. However, when you upload anything above 100 megabytes over a general internet connection, you might get timeouts, you might get other issues, and your downloads or your uploads might be affected. So what S3 really does is allows you this capability that you can break your object into multiple chunks. Your multiple chunks can be uploaded parallelly across the internet to S3, and then with just one command call, you can reassemble that particular object and then store and have it accessed in the general sense. If any of the chunk is not, fails, the upload actually fails due to a timeout or a load balancer timeout or something, then you can re-upload that's just that part, and you don't have to upload that entire object. So there are multiple such unique features that allow you to do multi-part uploads with up to 5 terabytes of object. All of this is handled by our SDKs, so you don't really have to worry about. And there are a variety of different ways you can take advantage of from our customer partner solutions as well. So when you have terabytes of data and you want to move it within days, of course, a lot of people talk about today about AWS Import Export, but I'd like to talk a little bit from a context that never underestimate the power of a FedEx box, right? Or never underestimate the power of station wagon packed with tapes, or not tapes, or hard drives. There may be much more faster way to move your initial migrate, upload data. If you have terabytes of data, FedEx that box to S3. Amazon.com has good experience with handling shipments, as you can imagine. Amazon will suck up all that data that you want to process in the bucket that you have provided in a simple manifest file. And you can encrypt your data and then store it. It's just bag of bits for Amazon. So you can encrypt your data, then store it, and then we'll restore that back into AWS, into Amazon S3. You can also put this as Amazon S3 EBS snapshot, so you can restore it back onto an EC2 instance very quickly. So there are different ways in which you can leverage and transfer large amounts of data and try out for your try out your application, whether it works or not, and so forth. The other flip side is the export. If you need to have disaster recovery and you would like to export all of your data, you can simply have an object expiration policy set on one of the bucket. After some time, all the data would be deleted from your S3 bucket, and your data will be exported, put it into a hard drive, shipped at your customer location. There's a customer called Complete Genomics, which essentially really takes your individual genomes, and it's a 4 terabyte of data. It actually ships to the computer scientist who is analyzing genomes based on the data that they have using the export feature. So they analyze it, they store it in S3, they ship the hard drive to the scientist at the lab and for genome sequencing in-house. There are a variety of different ways AWS Import Export can be leveraged. So if you want large amounts of data that want to be moved, this is one way to go. Of course, there are multiple solutions today from our partners, which was mentioned, Store Simple and others. If you have terabytes of data and you need it within the hours, and you want to periodically do your velocity within the hours that you need, then you can leverage some of the UDP transfer protocols where Aspera or open source software or like Tsunami UDP protocols can be leveraged to really get the throughput that you need. So I think John, in his Zencoder presentation, you're going to see how they use Aspera in a very interesting way. So this is how you would be able to leverage storing large amounts of data, the initial first upload that is needed in a variety of different ways. Now comes my best part, which is the compute and analytics. Now, the compute and analytics is really, of course, you can use Amazon EC2 in a normal setup if you don't want to use Hadoop. But if you would like to use Hadoop, Hadoop really gives you the power to do massive analytics with just few clicks. It abstracts out all the necessary muck, all the parallel computing nightmares, abstracts out all of that into one single web service call. You start up with one command line call, a complete Hadoop cluster. With just one API call, you can start that cluster, run your job, process your entire data set, and then shut off that entire infrastructure after your job is done. And you only pay for the hour that it's using. So it has fundamentally changed the way how parallel computing works. Parallel computing used to be an extremely difficult task in the past. And now it is a bunch of mappers and reducers that you have to write, which will give you the power to do pretty extraordinary things. And cloud computing on the top of Hadoop really gives the power of doing extraordinary analytics to any developer in the organization. So it makes it really affordable for everybody to get the necessary information or knowledge that you need. The second thing, which is one of the core elements of how cloud is leveraged, is to providing and leveraging the elasticity of the cloud. When I say elasticity, there are a variety of different ways you can leverage, but one of them is Amazon EC2 Spot instances. How many people know about Spot? Okay, few of them. So those who don't know, there are 3 ways to purchase an EC2 instance. One is you go with an on-demand EC2 instance, go online, launch an EC2 instance. It will be an on-demand EC2 instance. For 8.5 cents an hour, you will get a small EC2 instance with 1.75 gigabyte of RAM, 160 gigabyte of hard drive space, and 1 gigahertz of x86 processor. You can purchase the reserved instance, which is essentially that you are paying an upfront cost, one-time upfront cost, and you get your hourly rate is highly discounted. So in this case of small instance, you pay I think $69. $265 or so for a 3-year or a 1-year period, and then your on-demand rate of 8.5 cents an hour reduces to 3 cents an hour. So if you're running it for a 3-year period or a 1-year period, the reserved instance is the way to go to give you the maximum savings that is lowest cost. The third way to purchase an EC2 instance is to purchase and bid for unused EC2 capacity using Spot instances. So this allows us to actually increase the utilization of our own infrastructure, and then you set the price of that EC2 instance. That I want the price of that particular EC2 instance to be 3 cents an hour. If the capacity or if the EC2 instance is available at that particular price, which changes at the spot price every hour, your instances will be provisioned, your request will be granted, and your instances can be provisioned, and you can run those jobs that you need. The caveat is, of course, that if the spot price goes above the maximum bid price, your EC2 instances will be taken away. So you have to build your architecture such that you are ready to manage your interruption. So you maintain your state, you maintain your checkpoints, you maintain your application such that if the you can set a complete processing job and set a price tag on that job, saying that if I want this particular log of 10 terabytes to be processed only if my price is X. And it will provision your infrastructure. If it is going to take a little bit more time, it's okay. It will again resume the job when the new instances are available at that price. So it completely changes the way how economics of cloud computing work, and that's the best way to even further reduce your cost. The best way around cloud computing with Hadoop and EC2 is the ability to expand and shrink your running cluster. So you start up an EC2 instance, you start up an EMR, Elastic MapReduce cluster, which is a Hadoop service on top of EC2 and S3. You start with the entire cluster, and then you see that your job is taking a little bit more time than it should. Then you can add a little bit more number of EC2 instances on that on that cluster, expand your running cluster so you reduce your processing time, or shrink your cluster in order to save cost. So there are, Hadoop has the ability to take and expand your EC2 instances, the entire cluster in an effective way, so you can expand and shrink your cluster and reduce your processing time overall. And last but not the least, this is the 2-tier model that lots of our customers really take advantage of. After they have stored their results, after they have analyzed the results, they would like to store their pre-computed indices or pre-computed reports or their analyzed data into some sort of a relational database or Amazon DynamoDB. where they can have access to that pre-computed report almost seamlessly in access in real time. So this is two-tiered model. The first tier is really the batch tier, which expands and shrinks on ad hoc basis based on batch processing. The second tier is really the speed tier, where you store all your analyzed data and you have access to that particular data in a very effective, fast, seamless, SSD-powered DynamoDB. So you can get access to your data much more quicker, much more faster in a real-time way. And this is what gives you the power. This is where the cloud really shines, where you have an ability to not only store massive amounts of data, you not only have the ability to expand and shrink your running cluster and pay for only what you use and get the necessary capacity that you need to do your analytics and store that results, shut off that entire cluster later on, and then store all your results back into some sort of a relational database or S3, and then get that effective real-time access to your insights right away. This is what I really like about the cloud overall in general. So how Hadoop works is essentially you essentially specify your mapper, your reducer, you feed it to an Amazon Elastic MapReduce service. Amazon Elastic MapReduce service will spin up the Hadoop cluster. It will run parts of task node and the core nodes. These are essentially the nodes which are going sort of a master-slave model. Your name nodes is really your master node. Your slave nodes are task node and core nodes. You put your data back into a bucket or an Amazon DynamoDB, and you can run ad hoc queries, your data warehousing queries using Hive, Pig, or Cascading, any of these open source framework that run on top of Hadoop to give you the necessary insights that you need or the query that you would like to get. So this is the beauty about using everything in the cloud is that you can run all these tasks node on spot instances. So you have much more cost-effective model to process those data. As well as the entire cluster can be turned off if you want, and then you only run it on ad hoc basis. So you have terabytes of data of Clickstream logs that you would like to analyze every 2 hours at night. You only start your EC2 instances, your EMR cluster, for 2-hour time frame during the night. Do all the processing, create all the reports, shut off that cluster at 2 a.m. at night, and you have your results ready for the next morning. You only pay for that 2-hour time frame when your instances are run. So that's the beauty about the cloud of how you can leverage the on-demand nature in a most effective, cost-effective way. So this is where the cloud really shines, as I was mentioning. This is how AWS addresses some of the big data challenges from storing, computing, analyzing, and having access to your computed data in a fast, easy way. Now, what are some of the enterprises doing today? And this is the best part of the presentation, where you get to see some of the real-world stories of enterprises that are leveraging the big data cloud. Right? The first one, I have takeaways for you for these 4 stories that I'm going to talk about. The first one, with the cloud, you have an ability that if you're running one job on 100 instances, if you're running one job on one instance for 100 hours, the cost of that is going to be the same for if you run it on 100 instances, but you have the ability to choose between cost and time that you want your processing to be done within 1 hour. That 99 hours of savings that you get is extremely important when you are running really fast real-time reports that you would like to get. So in this, you have the ability to reduce your time to market, expand your cluster, make sure that you had that necessary compute horsepower you need to process your data much more quicker. So one of the examples here, one of my favorite examples here is Bankinter. Bankinter is a joint association between Bank of Santander and Bank of America, where they do real credits, real risk management analysis and credit risk simulations using Monte Carlo simulation on top of EC2. They're not using Hadoop, but they have their own infrastructure. They have their own infrastructure in place that will not only process that they run at every end of the week. They run 400 simulations on the cloud, and the time it used to take from 23 hours has been reduced to almost 20 minutes. And that's the power of not having to manage infrastructure, not having to manage this, getting enough capacity you need, and paying for only what you use for the jobs that you would like to analyze. So it's a perfect situation for a company like Bankinter doing real credit risk simulations on the cloud. The takeaway, which I would like to talk about, is this: every employee within the organization has the power to get this elastic supercomputer at the disposal to do pretty interesting things. Imagine how much your company would, as an aggregate, would achieve if every single employee, smart employee, has an ability to spin up the cluster they need to run the necessary business insight, run the necessary data, give you the necessary business insight so that you can take the right decisions. And this is possible only because now any employee can go online, sign up with a simple credit card, get access to massive infrastructure at compute. There are GPU instance types to large cluster compute instances which are essentially what I call the cloud HD or powerhouses of EC2 instance types. It includes 2 NVIDIA Tesla chips on one EC2 VM instance, so you can also do GPU type workloads, especially for your video transcoding needs. And there are cluster compute EC2 instances, which is another family of EC2 instance types that gives you full bisection bandwidth between 2 EC2 instances. 10 gig E bisection bandwidth between 2 EC2 instances, ideal for your high performance computing workloads. So this is how you can get a large amount with just $2.10 an hour, you can get a high cluster compute EC2 instance type with a full bisection bandwidth on EC2. So for that, the example here is Capital IQ. Most of you here know about Capital IQ, and they are one of the largest. They have lots and lots of data that they want to process, and they have built their recommendation engine which is powered on Amazon, on CapitalIQ.com. So every investment banker who is going in, they see this company you may be interested in box, right? That particular box on their website is powered by AWS. What it does essentially is they have that SQL server data set, and they are managing the data in-house on the SQL server. Every periodic interval, they BCP in the data in S3, run a complete EMR cluster of 16 nodes with one single command line call. Everything is completely automated. So they want to, you don't really have to do any plumbing or anything required. You can bootstrap that entire process in an effective way because everything has an API with cloud. So it runs a complete 16 node cluster, processes all that data, and dumps all the results back to S3, which is again a static way of delivering your data, which is available on their website. And they take that data, pump it back to the SQL server, which is again powered, and then their website essentially uses that. This they do almost every single time. Whenever new data sets are changing, they have integrated their existing SQL server back into the enterprise. Within just one of the teams within large Capital IQ organization, were able to come up with this innovative idea and recommend and power that recommend engine powered by the cloud itself. So this cloud gives you this enormous ability to to do pretty extraordinary things in run recommended engines, run interest framework, run log analysis in an effective way. The third takeaway is elasticity. And elasticity is the fundamental property of the cloud that drives most of the economic benefits, because you can turn your resources off when you don't need it. So you can turn off your entire cluster when you don't need it, and you can save, and you don't have to provision for peak capacity anymore. So that allows you to save on the infrastructure that you might probably run, that you might have in on-premise infrastructure that you have to have complete provision capacity. So in this is a real usage graph of one of the Wall Street firms doing, again, risk management analysis back in 2009, and they are continuing to use this service. So what you're seeing is a 300 instances baseline capacity that they have. Every Thursday of the week, they spike up to 3,000 EC2 instances to run their risk management analysis, have a complete flexible infrastructure at their disposal, and then come back down, get the data that they have from during the entire week, from Monday to Thursday, analyze in the next 3 days, and be ready for their reports and our analysis that they have to work on Monday morning or during the weekend. And you can imagine that all of this white space between the EC2 instances, the big spike, is their savings. The elasticity allows them to spike up from 300 instances to 3,000 instances every single week. And that's much more powerful framework than provisioning for peak capacity, having 3,000 instances always provisioned for it. So if you have an ability to turn off your infrastructure, you have ability to save much more heavily. You can build innovative architectures, essentially websites that sleep at night. So even if you have a large architecture that is currently running with a complete 3-tier web application, you can shrink your web and app tier from 5 servers to 2 servers and save on those during the night time. There is an ability to auto-scale your infrastructure using the auto-scaling service with S3, EC2, and auto-scaling service. However, this one is a big data processing analytics website use case where they have lots of data that they want to process, and they want to spike up and down based on the capacity that's there. Sometimes that graph is not that much because they don't have that much data. So they want to also move to around 1,000 instances instead of 3,000 instances. So the fourth one, which we talked about earlier as well, is the focusing on your business. And this one is one of my favorite use cases because I had an opportunity to talk to the CTO of Razorfish. So Razorfish is a company, is a digital advertising company, which essentially powers lots and lots of, has lots of infrastructure components in place. However, they reached a capacity limit. They were not able to take any more jobs or any more leads because they were spending more time on their infrastructure, being the storage experts, being something that they didn't want to be. They wanted to be an analysis expert. They wanted to be the insight expert overall. So they realized that there were much more important benefit that the company can do if they don't go into the storage infrastructure business versus focusing on the compute and analytics and asking the right questions that will drive business metrics. So a typical example, and this is one of the best examples of why you want to focus on what you do the best and outsource everything else which is not your core differentiating or core competency. In this one, a large online retailer went to Razorfish to analyze their logs. They were doing 3.5 billion records. They're doing web analytics records, Clickstream Log Analysis that comes every day, 13 terabytes of data that is being pumped every single day. What essentially they do is on the online website, on the retail website, If the customer has purchased, let's say, a sports movie, and they're searching for a video game, they will do targeted ad advertising, and then provide them the right analytical solution and provide them the right ad that, okay, you might want to buy this new video game which is related to sports, right? So overall, the previous scenario, the old way of doing things was they had SAN storage, they had 30 servers, they were running 3 high-end SQL servers, their business results were around $500,000 of capital expenditure. Now, significant recurring operating expenditure because they had to manage their infrastructure, software, components, also the complete infrastructure around Hadoop, as well as several other networking components and so forth. Processing time was around 2 months for every single job that happens every day for their analysis. And it took around, procurement time was 2 months and processing time was around 2 days for every single job. So it will be that results were very much delayed and the results were not coming out correctly as well because it takes a lot of time to process the data. With the new way of doing things, they really understood the value of focusing on the core businesses versus focusing on storage and infrastructure and compute pieces. Now they have zero capital expenditure, no upfront costs. They're running their costs, they're running their infrastructure all on demand. They are further reducing their cost by leveraging reserved instances, as well as their recurring operating expense is around $13,000 per month from highly significant from the last time. And your processing time is reduced to 8 hours from 2 days. And now you can see there's not only financial benefits, but also business metrics which are able to give valuable results much more quicker. It's the best way to go. In this scenario, they had around 500% more return on spend. They were able to spend more on actual delivering business insights, doing it better, making their results more relevant, and running more different types of algorithms on top of their existing. They had the power to experiment even more. So that's the key around how you can focus on your core pieces, which is driving more business metrics. In the large online retailer that Razorfish was contacted by, we were really happy with the results itself. So you can see that they're adding more resources towards analysis versus worrying about cost, worrying about storage, infrastructure, racking, stacking servers, and so forth. So these are the 3 takeaways today. As I said, why big data really matters today. It matters today because the data-first philosophy. You need to collect as much data as possible and run ad hoc queries, run massive computation in a variety of different ways. Cloud gives you the power to store data without limits, compute without limits, analytics without limits. AWS gives you several different tools today, like the Elastic MapReduce, which is a Hadoop service, gives you an import-export to actually pump in lots of data in a short period of time, as well as a variety of different tools like DynamoDB, as well as the other tools that will help you get access to high-throughput, low-latency distributed databases. And there are a variety of different studies that are there, real enterprises leveraging it today. If you feel that if there are any questions around this or how you can leverage large amounts of data and in the cloud, process it, start off with a simple job, simple prototype, a proof of concept, and you will realize that it has much more benefit than going through these big cycles of enterprises and talking to her. Have a simple prototype, proof of concept, started, which will show you and give you results very, very quickly. So with this big data dog, I would like to thank you to all of you for being here, and thank you very much. Feel free to send me an email later, and I'll be more than happy to answer. Thanks.